Yes, welcome to second part. We will now continue to presentation and question, one of the questions. Okay, not this question. Okay, we were talking this one and here. So let's look at here. You can see that if the refractive index of first and the second medium is equal to each other, there is no refraction, there is no refraction. Okay. I would like to share my screen here. We were talking about this one, I think. Here. Okay. Yes, you can see that if the refractive index of two different medium is equal to each other, there is no refraction or reflection. If these are not equal to each other, reflection will be occur. Refraction depends on the refractive index of the two different medium. Here you can see that there are some reflectance values. What was the reflectance? Please remember that here you can see the formula. Reflectance value is abbreviated with rho symbol, okay, rho character. This rho is equals to the IR divided by I0. What is IR? Light intensity of light, which is coming, incident light, and this is the reflected light, intensity of reflected light divided by intensity of incident light. Okay, so reflectance value of some different media are in the table. Let's look at the table. For example, glass air surface has a reflectance value, spectral reflectance value. What is spectral? The smooth surfaces exist and the lights are coming and reflected in the parallel direction. The value is 0.0403. For example, glass water, glass 1 molar potassium chloride, glass benzene. So, with the help of this data, what can we do? If we can design a small instrument, can measure the reflectance value of different media, what type of analysis can be performed by the help of this instrument, small instrument or device? Do you have an idea? No idea. For example, qualitative analysis can be performed. If you know the reflectance value of one media and the others are not known, so you can measure the reflectance value and compare with the tables and calculate the unknown medium refractive index or intensity of light, and you can make a qualitative analysis. Which material is this? Water, potassium chloride, benzene, sapphire, sodium chloride, and etc. Here, there are some refractive index values of materials at 20 degrees. Here, you can compare them. These are the reflectance values. These are different from each other. Okay, here we should give two combination, glass, air, glass, water, glass, benzene, sapphire, air, sapphire, water, etc. There should be a two components for the reflectance value. But in refractive index values, you are just giving a one material like that. Okay, benzene and etc. Let's look at it. Glass and air. Air has a 1.003 refractive index. And what about glass? There is glass silica, for example, type of borosilicate, a type of another glass, and crown glass. Here, there is a difference between the refractive indexes. So, reflection should be occur here. Crystal quartz, magnesium chloride, potassium iodide, potassium bromide, silver chloride, and calcite, benzene, and etc. These are the good examples. And let's look at the question 7. Up to now, we see 6 questions. This is the 7th one. Let's look at the question. How much decrease in intensity of ray will be occurred when a radiation with wavelength 589 nanometer passes through the quartz cell filled with water? So do you think which equation should we use to calculate the decrease in intensity? Which equation? This reflectance equation. Why? Because we know that the intensity of radiation is changing with the difference of the two media. So we are changing the media and intensity will be changed. And if we have the value of N, glass, air, quartz, and water. Where is water? Water. Yes, here, water. Water has a refractive index of 1.333, air 1.000, and quartz. Where is quartz? Here, this is quartz, pieced quartz. So, how can we solve this problem? Please think about in a minute. Wavelength is always same in the questions. Don't confuse your mind. Always using the same wavelength. There is no problem with the wavelength now. And let's look at the question 7. How much decrease in intensity of ray will be occurred when a radiation with wavelength 589 nanometer passes through the quartz cell filled with water? So let me draw the proper figure and try to understand the solution. Maybe here. I think you can see my page now. So let's look at the question 7. Here you have a material filled with water, okay? Water. I think this is quartz glass. Quartz material or not? Let me see the question. quartz cell. Yes, this is quartz cell. Quartz cell. Wavelength is 589 nanometer. And this is hitting to the surface. And what is the decrease in intensity? Decrease in intensity. He's asking. Okay. So let me draw this one. Here, you can see that the radiation is coming. This is a normal line, for example. Radiation is coming. Okay, the radiation is coming. The I0, okay. And there is a reflection here. Okay. In the air quartz, here, this is air part, this is quartz part, and this is water. So first, reflection. First reflection will be occur between the air and the quartz, because radiation comes to the surface of the quartz cell, hitting to the quartz, and from air to the quartz, the radiation should be hit to the surface, and some will be refracted and some will be reflected, and some will be reflected. Okay, some will be reflected. This is ER. Okay, ER. E0 and ER. First reflection will be occurred like that. Some other radiation go to the inside of the water. And here at that surface, second reflection will be occur. Quartz water surface. Okay, quartz water surface. Here, quartz water surface. And here another reflection and refraction process will be occurred inside of it. Again here, third reflection will be occurred with the water quartz surface here, water quartz surface. And when leaving from the quartz cell, fourth reflection will be occur quartz air. Quartz air here. Quartz air. So we will see four reflection process here. Air, quartz, water, quartz, air. Because the radiation is coming here from air to the quartz, there is a reflection. Quartz to the water to the quartz to the air. Okay, so for reflection process will be occur here. Okay. Here you can see that we have an equation like that. it was like that. Okay, so this is the intensity of coming light, and this is the intensity of radiated light, reflected light. So remaining part is continue its way. So for the first reflection, we can make first reflection air quartz. You can say that ER E0 N2 minus N1 to do N2 plus N1. So this is N2. What is N2 here? N1 is air, N2 is quartz. Air is, what is the air value? And what is the quartz value? Let me check this one on the presentation. I will check the value for air. 1.003, and for quartz plus fused quartz water fused quartz. Let me actually call fused quartz. Here, another table. I'm checking. Silica quartz. Okay, in the table, 1.548. No, this is not like that, I think. This is a 313 nanometer, however. We are searching for the same quartz. Okay, this is in the same table, fused quartz, 1.458. This is, and maybe the water, okay. So, and 2 is 1.4. Let me return to the Zoom. Okay, 1.458 minus, because N2 is this and 1 is this, 1.003 square divided by 1.848 square. So let me make this calculation. Here, this calculation. So 0.405 square and 246 square. Two point 461 square and this is 0.024. Okay, so let me write that here. IR divided by I0 is 0.04 point divided by 1. That means if you send an intensity for 1, The reflected one is 0.034. What does it mean? This means that if it is 100, this is 3.4. This is okay. The 3.4% of the light intensity is reflected, and this remaining part is here. This percentage has been reflected. Okay, reflected. IR to I0 is in this ratio. What does it mean? I remained? Remained intensity is I0 to the IR. If this is this value, for example, 1 or 100, the value will be like that. Percent remained. Okay. Here, this one, 3.4% reflected and 96.9% remained to continue its way in the glass beaker. The glass beaker. This is the first reflection. What about the second reflection? Second reflection occurred with quartz water. So N1 is quartz, N2 is water. What is N1? 1.458 and 2 is water. Water is 1.333. Okay, 333. So let me make calculation IR over I0 equals to the N2 minus N1 square, N2 plus N1 square. What does it mean? N2, 1.333 minus 48 square and 1.333 plus 1.458 square. Never mind, this will be negative result. However, when you take the square of the negative value, it will give the positive value automatically. So let me write here. Minus 0.125 square and 2.791 square. This is going to 0.0 2.791. So the value is the calculations right? Let me check. Minus 1.458. Okay, take care of it. Okay, this is okay. So divided by 7.7896. This is 0.002. Okay, so let me write here IR over I0 is equal to the 0.002 for 1. For 100, this is like that. So percent value is like that, reflected percentage. This is reflected percentage. So what about this one? It is coming from the other section like percent IR is 0.002. IR is 1.1920. So what is the remaining part? Remained is minus this one. Percent remained. Okay. So let me go to the third reflection. In the third reflection, remember that here, water quartz, N1, N2, N1, N2, what is quartz? So same calculation will be here. I think the same result will be come here. Result will be the same, 0.002. So again, IR, I0, 96.2, IR, and etc. It is going like that. So what about the time now? Maybe I can finish and make a longer course for you today. So this is the reflected amount, okay? Is it right? I will check again, 0.002. And here, 96.42 multiplied by 0.002. This is 0.193 again. Here. I remained 96.2 minus, and here the remaining intensity of light is here. So the last reflection is here, fourth one. Please remember the fourth one here. reflection with quartz air again. Reflection, quartz air. So now N1 is quartz and 2 is air. N1 and 2. Quartz was 1.458 and air is 1.003. IR, I0, we have performed in the first section this one here. Same calculation is coming and the ratio is 0.034. This ratio will be 0.034. What about this one? This one is 96.20. So IR, reflected part, is now 3.272. So I remained is 96.22 minus 7. $92.9. So what was the question asking? Let me read the question again. Question 7. Question 7 is asking how much decrease in intensity? How much decrease in intensity? How much decrease in intensity? How much decrease in intensity of the radiation? First, you should know that originally we took 100% and I remained intensity was 92.96. So what is the difference? I will give the exact value. .04% of the light has been decreased due to the reflection processes. Okay, we take the difference for the beginning 100% to the remaining intensity. The difference between the beginning and the remaining intensity gives the decreased percent of the intensity. 7.04% of the light intensity is decreased due to the poor reflection process. So this is the end of the 7th question. So I will also upload the solution steps to the system. So this is the end of the 2nd part. See you in the next week on next items. Sure. So I am ending the meeting. Have a nice day for all of you. See you next week.
See you.
See you.